Hello and welcome to the another series of Learning C. Today I want to explain about bit operation. So as its name suggests, bit operation is operation between bit which is only contain value 1 or 0. So yeah, first I want to explain about the basic operation in bit. And the basic operation there are and, or, exclusive or, and not, or you can say it negation. First is and. So in and the rule is it's quite simple. When 1 here meet 1, it will be resulting to 1. And 0 meet 0 resulting to 0, and 1 meet 0 will be resulting to 0. So the only operation that will be resulting to 1 is just 1 meet 1, just if all the bit is 1. Okay, and this is the form of if you want to do an operation. Here I declare var1 and var2, and then here rest is a char variable. Oh yeah, in here this is the way to declare this is the way to declare the variable, but in the bit form. So as you know that char have a 1 byte, and 1 byte have a 8 bit. So here I declare 8 bit. There is a 8 digit here. Yeah. Okay. Let's just compile this. Oh, I forgot to do a return here. So the program will be stopped here. Rest n minus 128. Let's see its form in the binary. So in binary it will be have this form. You see here 1 meet 1 resulting to 1, right? 0 meet 0, 0, and 0 meet 1, 0. So that's it. Next is OR. So in OR, here I'm doing OR var1 with var2, same with here, but now I'm using OR. In OR, it's quite simple that if any one of them, if any bit in var1 and var2 meet and one of them is 1, it will be resulting to 1. The only operation that will be resulting to 0 is only if 0 meets 0 like this. So let's see if I change this to 0. Turn 0 here. Let's compile this. It's resulting to minus 127. And minus 127 have a form like this. See? 0, 0 meet 1, 1. And 1 meet 0, 1, 2. But let's see if 1 meet 1. It must be same, right? So here the result is same. 1 meet 1. Okay, now exclusive OR. As its name suggests, exclusive OR is like OR, but there is another rule that if 1 meet 1, it will be resulting to 0. The only operation that will be resulting to 1 is if 0 meet 1. So let's see. Let's compile this. Minus 111. See here, 1 meet 0, 1. And in the third place here, 1 meet 1, we see here, it's resulting to 0, right? 1 meet 1 resulting to 0. 0 meet 0 resulting to 0 too. 1 meet 0, yeah, 1 meet 0 in the end resulting to 1. And that is how exclusive OR work or SOR. Now here is negation or not. So in negation, it's quite different with the other three operations. It's only need one variable. It's basically a flip bit. We'll be doing a flip bit here. So when 0 need the, so when 0 meet this negation, it will be turned to 1, but if 1, it will be turned to 0. So it's like the reverse. Let's see here, I'm doing negation for var3. Let's compile this. 95. Okay, what's the form of 95 in binary? See, all the bit is flipped. All the 0 become 1 and all 1 become 0. And that's it. Okay, actually there's another bit operation. It's called bit shift. So bit shift, it's like it's just its name suggests, it's shifting like here. The one here it's the one here is in the third place, right? But if I shift this with 2, this one here will be placed to here, and 1 in here will be placed to here in the third place. If you want to understand it more, let's just do this, okay? And it resulting to minus 24. What is binary form? You see here, the 1 in here, it's placed in here, and 1 in here placed in the third place. And then the bit before the 1. So as you can see here, before I shift this bit, in the first place we have a 1, but if the variable that we shift that in the first place it's have 1, the trailing of this first place, look here, this is the 1 in the third place, the trailing will be 1 too. But what if we change this to 0? It resulting to 8, and 8 have the form in, look, you see here, all the 1 is changed to 0, and 0 in the first place in here move to the third place, and its trailing is 0 too. You see, that's what I mean. Okay, I think it's clear. And then now it's I think this is the practical form in bit operation. So you see, when you using C, you will see you will meet set flag like this. So in C, when you programming in C, most of the time you will use it for low level programming or low level, yeah. It's the what I mean is most of the time you will playing with bit and binary like this. Empty flag is a char, and char have a size 1 byte. 1 byte have 8 bit. So in 8 bit here we have 8 slot for the flag. In the early code I already defined here flag 1, flag 2, flag 3. Flag 1 have a flag position in the last place. Here flag 2 in the second last place and flag 3 in the third last place. So if you happen to meet with this argument, it's like what the meaning of this argument is, it's activating the flag like flag 1. It will be do the activating when I say activating it, like making the bit in that position become 1. So when I activate flag 1 like this, I'm using OR here. It's like I make sure that the last bit here in empty flag here will have a 1 in the last place. And when activating flag 3 here, it's like I make sure that in the last third place here have a 1, or its bit is active. We can say its bit is active. Okay, so let's see. 5 and 5 have a binary form. You see here the last place or flag 1 and the flag 3, it's active. The last place have a 1 and the third last place have a 1 too. What if we active all the flag? 7 have a form. You see here all the flag is active. Last place, second last place and third last place. Okay, now how we can check if the flag or bit is active. Okay, and the answer is with this operation. Here I'm doing this. Okay, I declare A as 111, so all the bit is active or 1, and then char B is like this. We want to make sure that bit in this place, and here the last place is active. So first here I doing a AND operation, and then if this is resulting with here I am using B here. Yeah, this is the operation to make sure that the B here or the bit in here, and here is active. So let's see. As you can see, char A is all is 1. So it must be true, right? Oh, let's place return 0. here the result is 1. The meaning of 1 here is it's true that B or the bit in here, let's see, this is the 4th place bit, the 6th place bit, and the last place bit is active. Now what if I'm doing or I reverse the position here? Instead of after twice equal here, I am placing the B here, but now I am placing the A here after twice or double equal here. But the meaning of this is the opposite of B. Now the checker is A, so I want to make sure that in B, if all of this bit is active, if all from 1 to 8 all is 1, the answer will be false, right? Or this is will be not true, right? Let's see. Yeah, it's resulting to 0 because in B, not all bit is 1 or not all bit is active. Okay, I think that's all. I hope you understand my explanation. See you in the another video. Bye.